Okay, so let's continue. General physiology. Sodium potassium pump. It's an electrogenic pump. 3:2 is the ratio. 3 sodium comes out and 2 potassium goes in. Okay, energy is required in this process, discovered by Genskov, present in all cells. It is present in all cells. Okay, there are two subunits present in sodium potassium pump, that's alpha and beta. Three subunits are present in kidney cell. Okay, don't confuse. Three subunits are present in kidney cells, two subunits are present here. Okay, alpha and beta. This is alpha orange one and this is beta green one. Okay, alpha is the mean catalytic unit and beta supports and increase the affinity of ATP. Okay, further alpha has 5 binding sites. Okay, first site bind to sodium, second to ATP, third is phosphorylation site, fourth binds to potassium, and fifth is ubiquitous binding site. Okay, fourth and fifth are outside the cell and these three are inside. Okay, then function of sodium potassium pump is resting membrane potential. It works minimal, we have seen in the first video. Maximum done by calcium, opening of the calcium channels, and second minimal minus 5 millivolt, and this is minus 85 millivolt. Basement membrane, basal metabolic rate or basal energy exchange, it regulates. Then donors equilibrium is opposed here, just have to remember the name. Donors equilibrium is opposed here. Okay, charging of excitable cells. Okay, recharging of excitable cells occur here. Okay, then its main function is it maintains the cell volume. Okay, it maintains the cell volume. Regulations of sodium potassium pump are what are the things which regulate aldosterone, thyroid hormones, insulin and catecholamines. Aldosterone increases the number and increases the activity of resting membrane potential. Thyroid hormones just increases the number, and then insulin increases activity. There's a farmer question in DKA, especially DKA, diabetic ketoacidosis, we give insulin. Okay, so there's a chance of hypokalemia to occur. Okay, so we have to be very cautious while giving insulin in DKA patients. Okay, because due to insulin increase activity of sodium potassium pumps, and you know and hypokalemia can occur. Okay, then catecholamines. The decreased sodium potassium pumps are done by 3Ds and 1A. 3D is digitalase, dopamine, diuretics, and ANP. Then feedback homeostasis, which homeostasis is given by W.B. Cannon. Feedback mechanisms are of two types. There are two types from which we can. There are two things from which we can control the homeostasis of our body: feedback mechanism and feed forward mechanism. Feedback is more common, in which negative feedback is very more common than positive feedback. Okay, here change occurred. It is opposite of what was going on, and this is no change occurred here, but body anticipates and controller acts. Okay, feed forward, more speed, less time, less error occur here. Okay, in feed forward, like some examples are there, like we have seen in GIT. Cephalic phase is the feed forward state. When we see food or smell it, saliva secretes, that's feed forward. Okay, for in okay, then if environment temperature decreases, this cold outside, before body temperature goes down, shivering occurs too, that's feed forward. Okay, then thermoreceptors in skin is feed forward, and thermoreceptors in body is feed back mechanism, negative feed especially. Then third example of feed forward is just start while exercising, we just at the start of exercising, increase psychic stimulation and increase ventilation occur. Then feedback in negative feedback and positive feedback. Negative feedback is more common in hormone, like in hypothalamus, TRH, TRH secretes and it goes to pituitary, then TSH secretes, it goes to thyroid gland, and then T3 T4 increases. When T3 T4 increases, it gives negative feedback to stop releasing it if it is an excess quantity. Okay, negative feedback, then it from pituitary it goes to hypothalamus, the negative feedback. Effect is opposite to the cause, opposite change occurs here. Then positive, mnemonic is clasp, here clotting, LH surge, action potential, shock, parturition, childbirth, oxytocin. In these are feedback positive, means they go, and if these are secreting, they go and give the feedback positive effect to generate more of them. Okay, like for example in during parturition, child takes his first air. Okay, then expansion of lungs occur and it increases day by day, it not increases expansion, but yeah, the process continuing, no, or respiration process is continued. Then gain, what is gain? Gain is correction upon error. Okay, if correction increases, gain increases. If error decreases, gain increases. Okay, for example, if a person A has a BP of 100 mmHg, after exercise or something, he has a BP of 175 mmHg. Then baroreceptors are the receptor in heart. It controls, baroreceptor reflex controls it and decreases it up to 125. Still 25 is not 25 is less. So here, what how much increased correction done by baroreceptor is minus 50 and error is 25 also, so gain comes minus 2. Okay, then gain is infinite. Okay, gain is infinite for kidney there, since error is 0. Error is 0, so gain is infinite for kidney. Volume regulation by kidney. Then exercise, there's a graph, ventilation versus time graph. Here at the start, this is the exercise period, this is recovery period, and this is rest period. At rest period, uh, it is normal. Then the green one, feed forward mechanism, abrupt increase of ventilation here. Okay, at the onset of exercise only. Okay, then brief pause, here brief pause, and then blue one, and then orange one, gradual rise. Gradual rise occurs. Okay, yeah, so feed forward and abrupt rise of ventilation here because of psychic stimulus and afferent impulses of proprioception in muscle, tendon, and joint. Because of psychic stimulation and afferent impulses of proprioception in muscle, tendon, it occurs because of psychic stimulation and afferent impulses of proprioception in muscle, tendons, and joints. And gradual rise occurs because of humoral responses, increased sensitivity to neuron to carbon dioxide, and increased plasma potassium. Then CVS, increase heart rate, increase stroke volume, increase cardiac output. Okay, normal resting cardiac output is 5 liters. During exercise it increases up to 24 to 35 liters. Then increased muscle blood flow occur. Then blood supply to organ increases in skeletal muscle, heart, and lung. Normal, it stays normal in brain and skin, and it decreases in inactive muscle, liver, GIT, kidney. O2 dissociation curve while exercising, right shift, and 2-3 DPG increases. Then muscle energy system. Muscle energy system are of 3 types: phosphagen system, which is the quickest form of energy, anaerobic or lactate, and then aerobic, low power or high capacity. Central thermosystem. Okay. Then BMR, basal metabolic rate. At metabolic rate is metabolic rate at rest, but after 12 hours of sleep or restful sleep at temperature 25 degrees Celsius and free from illness is known as basal metabolic rate. Then it is expressed as kilocalorie per meter square per BSA, body surface area, per hour. Okay, then mostly related to lean body weight. body mass. Okay, lean body mass is mostly related, then body mass, then body surface area, then body weight, then body mass index, and then height. Okay, so lean body mass equal is the mass without fat. It shows metabolic active tissue of body. Factors which affect BMR. BMR decreases with age. Okay, as the age decreases, BMR decreases. So in kids, BMR is high. Okay, then in males, BMR is high because the fat is less in males. So that's why. Okay, basal lean body mass is more in males as compared to females because the adipose tissues is less in males. Then such starvation decreases BMR. Then pregnancy, lactation, and growth period increases BMR. Main hormone is which control BMR is thyroxine. Also, some hormones which control growth hormone, epinephrine, norepinephrine. Then tall and thin person has increased BMR. Fat and short person have decreased BMR. The reason body surface area can be same, but lean body mass is different because tall, thin, and fat, short has same body surface area, but the lean body mass is different. That's why it is different. Body basal metabolic rate is different. Then what is resting membrane rate? It is also is resting energy expenditure is equals to BMR plus energy required for food to metabolize. Then that is resting metabolic rate. Then what is specific dynamic action? It is obligatory energy required to digest food. Specific dynamic action. In thermogenic, energy required and heat is released. Respiratory quotient is during metabolism how much carbon dioxide is produced and O2 is released. O2 is used. Okay, per unit time is known as respiratory quotient. Respiratory quotient for carbohydrate it is 1. In proteins it is 0. For proteins it is 0.82 and for fat 0.7. Then there's a question came. Okay, extracellular matrix related to extracellular matrix which is specialized glycoprotein. Okay, extracellular which is specialized glycoprotein. This is the question in which this is not given labeling, and it give pink one is give as B point and asked what is B. So we have to remember the labeling. This is collagen, this is fibronectin, this is integrin, and this is actin. Okay, fibronectin is a glycoprotein which joins collagen to cell membrane. It works as adhesion. Laminin is most common glycoprotein of basal lamina and also binds to collagen 4. Sorry, 4. It is not 6. It is 4. Okay, then when vetronectin is extracellular matrix in serum. Then CAM, cell adhesion molecule. Cell interaction between two cells because of CAM. Okay, because of these molecules: adherin, cadherin, selectins, and immunoglobulin. Cadherin is calcium dependent. Adhesion CAM. Then cell junction. There are of 3 types of tight junction: desmosomes, gap junction, and hemidesmosomes. Okay, so first is tight junction. It is present apically. It is apically present. It is very tight. No space between cells. Okay, examples. It is made up of occludins and claudins proteins. Claudin and occludin proteins. So it is also called as zona occludens. Okay, examples are blood-brain barrier and choroid plexus. Okay, second is desmosomes, also called as zona adherens, present in skin. It is present in skin desmosomes. Okay, it is made up of cadherins. Also, desmosomes is a protein with the filaments. Desmosome is a protein with filaments. Okay, space between cells is 15 to 20 nanometer. In gap junction is 2 to 4 nanometer. Space is present, made up of connexin. 6 connexin makes a connexon. Example, it is present in cardiac muscles and smooth muscles. In cardiac muscles to electrically synapse channels to rapid transport of the potential. Then hamidasparin combines with the base-limbapsin. Okay, this is now our general physio is done.